All right, here's lesson 4.5, isosceles in equilateral triangles. We are going to learn a couple theorems about isosceles in equilateral triangles and apply properties of those. So, again, I'm just going to whip through some parts of this, and you can pause and try to do the problems first if you want. All right, an isosceles triangle theorem. We'll abbreviate this one ITT. And then, so if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Converse of the isosceles triangle theorem, if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So we're going to use the isosceles triangle theorem here. Is segment GK congruent to HK? Explain. So GK, is that congruent to HK? And it is because of these two angles. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So we can label those like that. So A, yes. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. And that is the converse of the isosceles triangle theorem. This looks like a pi symbol there. All right, ITT. And part B is HL congruent to JK. HL, this little part here, and JK. I don't think we have anything to lead us to believe that those are congruent. We would need maybe this congruent to those, and then we could get that. So I'm going to say no. The angles opposite are not congruent. All right. So here's problem one. Go ahead and pause if you want to try and do it, and then check your answers. All right, we're going to find the value of x using the isosceles triangle theorems. So we can say that 7x minus 10 is equal to 3x plus 6, and that is by the converse of the isosceles triangle theorem. Then we can say 4x minus 10 is equal to 6, and that's by the subtraction property of equality. And we can say 4x equals 16 by the addition property of equality. And we can say x is equal to 4 by the division property of equality. Go ahead and try that next problem. Pause if you'd like. Okay, here's some corollaries to that. These deal with equilateral triangles. If the triangle is equilateral, then the triangle is angular, and I think we'll just call that the equilateral triangle theorem. And then if a triangle is equiangular, then the triangle is equilateral. We'll call that the converse of the equilateral triangle theorem. Okay, so problem 3. Triangle PLN is congruent to LNS. What is the measure of angle S in the figure below? We'll find that. Angle PLN is congruent to angle LNS. That's given. And then the measure of angle PLN is equal to the measure of angle LNS, which is 50. And then by the isosceles triangle theorem, we have angle S is congruent to angle NLS. And so the measure of angle S plus the measure of angle NLS plus the measure of angle LNS is equal to 180, and that's the triangle angle sum theorem. Now we'll substitute for some of these. We get the measure of angle S plus the measure of angle S plus 50 is equal to 180. That means 2 times the measure of angle S is equal to 130, which means the measure of angle S is equal to 130 divided by 2, which is 65. And that's the end of the video. I'll see you tomorrow, and we'll work on this.